is Henry Games.
Yeah, like use a bunch of logic gates and all the qubits that you have on your end, and they do a bunch of stuff on theirs. What you say, like what they call it when that happens, you're increasing the entropy of the entanglement. Because as soon as you interact, you know, like say that you have, I don't know, a freaking, you have like one particle here, and another particle here.
I think they'll have to look at the screen to be able to see what you're doing.
That's what I'm trying to do. So like, you say that they're entangled by drawing this line between them, and so you have this, and this is like the entanglement link. But then say that you have a third particle here, and this one is entangled with this one. So now you have this, and so basically if you learn something about this, you're also learning something about this. And so then you represent that link like this. And so you have this tree that grows out from, you know, perhaps more particles.
I've been explaining this for a while and just been doing it. So now
Yeah.
It's so great. Like, actually, now I can do it like this. Shit, this is gonna be awesome. I've never been able to do this because there's no way to, like, represent it in 3D.
Oh, so when it's branching out, oh my god, yeah, it's only like tri-exponential or whatever you would call that.
Yeah. I mean, the crazy shit is like in an actual physical system where you have quantum mechanical stuff interacting, it's gonna like be all sorts of fucking crazy, where you have like this one, and it's like this, and this one where it's like this, and this one going down here, and you know, all sorts of crazy shit. And that's just like regular mechanics. The thing that I'm working on is like, say you have those entangled things. Yeah, I'm like running out of space here.
Just clear it.
That's a good point.
There's an eraser and a clear.
Yeah, take
A lot of the stuff I built stuff
Where's it?
so a lot of the stuff.
What are you looking for, clear or eraser?
I think I'm just gonna clear it. Where is that?
Scroll over. There you go.
3 worlds and 3 games and 2
Bam.
VR.
Okay.
Which
I
is
don't know
pretty
why. I
freaking
guess it's
awesome.
just a familiar mechanic. So let's go back where we have like
So there was
a
around hot
particle
water.
here, here,
Yeah, it should be enough.
here,
Should be enough. And there's also, if it's too hot too, you could actually also use some water from here. Filtered water.
just stick
And
it
you could
over
actually
here.
like.
usually hang
And so you have your bridge that goes
I haven't
there.
hung out with
I'd probably let it steam hot water for a little bit
Yeah,
first,
totally.
just so it can get
And
the
then
water
the
flavor.
Oh.
That bridge.
as opposed
This
to.
is pretty cool to watch them do this.
Thanks, though.
it's easier to understand when you can draw it instead of just saying here and here and here and here.
Hey, here's your, it's hot, but it's your green. It's your clear green.
Still a
Give me that
little
cap,
bit
you
hard
use this
getting
week.
that depth perception
Yeah,
down.
nice package away.
Well, walk around it and you can tell where it is.
Yeah, it's a little easier. If I stand back
Should be hot.
and I go a little slower, I can kind of get it.
Looks kind of porcupine-ish.
Whatever. I'm getting there. It's like a really rough drawing, which means it's gonna kind of be a little bit harder to tell what the hell's going on. But I'll try and like get there. Blah. You got blah. There.
Keep in mind we can't see in 3D. Like we're seeing a 2D representation of your.
Okay.
So, if you
No,
want
but
us
it's
to,
still, I can still see what
if
you're
you want us to
saying.
see it, walk around it.
Yeah. Well, it's not really supposed to be 3D.
Yeah.
Yeah, it's doing what it's supposed to do. I'm getting there. It's like super crazy rough, but whatever.
So if they lead inwards, is there like a singularity or something?
Yeah, so like here in the middle, all this stuff merges and it goes into that.
Right.
And when you get there, essentially the geometry, like say that you just draw a line that represents the outside of all of this. And this is like, sort of like you could call it the outside of like the universe or whatever. And then say that you want to say, okay, what is the entanglement entropy of the system? Because really it's just a series of the ones that I had that were like this and this, where they were entangled. But then you had like more of them, except when they went all the way around the circle.
What do you mean?
Have you seen Inception?
There.
Mm-hmm.
And so you have them all around in a circle.
Actually,
And if you want to say what the entanglement entropy of the system is, you basically choose a point on the outside and you draw across it while
I think some of the
covering
friends
the
are
least
over.
number of links that you can.
And we
And
have.
then you count the number of links that are there. And that gives you a measure of the entanglement entropy. And
And I think one of my friends
that
is having
amount
to
correlates to this weird thing. Like, have you ever seen Escher's paintings where it has like the angels and the demons? And they sort of mesh out and grow up by the edge. They're like an infinity of them.
Right.
So that is what they call, that was a mathematical, pictorial representation of what they call anti-de Sitter space. if you draw that out in time, it kind of looks like a big old bucket, which is kind of, or a paint bucket or something.
Careful, you're stepping on the vibe cable.
What?
Oh,
I mean, like, it's not that big of a deal.
Yeah. It's not, I just didn't want to
Yeah, you
have
don't
it
want him tripping, yeah.
trip up and fall, you know?
so you have like this geometry and all that. Basically, this geometry corresponds to that, you know, like if you were to draw a line across that anti-de Sitter space, across that Escher painting, it corresponds to that. And so there's this weird dimensionality that corresponds between this whole clusterfuck, which you would say is really complicated in a quantum field theory.
Right.
To
To a line.
yeah,
To a parabola.
yeah, it's what they call a geodesic. So sort of like the shortest space between 2 points in space.
Weren't you
is-
saying something about light following that?
Yeah, light always follows that shortest length. Technically, it expands out in a wave, but you know, when you expand out in a wave, part of you is going to take the shortest way. Yeah, yeah. And so, really, this whole thing is what space-time should look like in this hyperbolic way, this like fractaling out way. Unfortunately, our universe doesn't actually look like that, so there has to be some way to relate the two. And you know, that's like what I do is I try and like relate these two things. I feel like I'm really close to the wall here.
You're not.
Okay. Yeah. So this is what I'm doing. I'm figuring out this, and right now people are-
Wait, keep looking there. Oh, look at this. It looks really cool. It's like an eye with like a mouth.
Oh.
And then you have the planets like a twinkle in the eye.
Wow.
That's pretty awesome.
Yeah, this little thing right there.
Yeah.
Yeah, this is what I'm working on. Some people are doing some experimental tests where they have like this complicated system and what they call Bose-Einstein condensate. And so rather than doing all the complicated math to predict the behavior of it, they're using this math to say it should act like something in there.
Right.
What I want to do is I want to take this stuff and I want to build a machine basically that does something to space-time.
Right.
So I just want to go the other way. Most people are going this way,
Yeah.
and I want to go that way. And some people are obviously doing that because being able to control gravity is obviously a good thing.
Well, you have to go both ways at the same time, right? Like macro
Yeah.
and micro.
Yeah.
So, yeah. That's awesome.